We're going to get into lesson 2, function notation. We're going to underline some keywords and phrases here. What you have to understand about functions is that they are tools that convert inputs to outputs. Okay? They have an independent and a dependent variable. And then we use a special notation for this. It's commonly used to show this conversion process. Okay, you put something in, you get something out. So here's how we're going to do that in the first exercise. It says evaluate, which means do the math. All you have to do is plug in the input values that they give you. Okay, so in this given function, here is our input, and this is the process, and whatever we get is our output. So we're going to take this 3 and make that our input now instead of x. So we would do 5 times 3 minus 2. Okay, and then you follow PEMDAS. Same thing here. We're going to put negative 2 as our input in the space where x is in this process. So we do 5 times negative 2 minus 2. So you guys should do that for all of these. You're just subbing in the value that they give you, the input for x in the function to get your output, which is your answer. Okay, the next part here just talks to you about function notation. This bothers me because I feel like it's backwards. We read from left to right. So to me, it seems like input should be the start and output should be the end, but for some reason you start with your output and then you have the rule, which is the process that you go through to get your output, and then x is your input. But if you can just remember that x is always your input and y is your output, then you'll be fine. So another way that we can use functions is in a table. So in this next exercise, okay, we've got a scenario where you have boiling water, which is at 212 degrees Fahrenheit. It's left in a room with the room is 65 degrees Fahrenheit, and it's left to cool, okay? So temperature readings are taken each hour. That's what this is. H is the hours. So going this way, that's your hours. Going this way, this is your temperature. So in this particular scenario, the temperature, T, is a function of the number of hours, H. So this says evaluate, again, just plug this in, the temperature after 2 hours or the temperature after 6 hours. So all you have to do is go up here to your handy dandy chart. Oh, here's 2, okay, what is the temperature? 104. Here's 6, what is the temperature? 68. Then they want you to see if you can read the chart backwards. I bet you can. You've got what value of H is the temperature 76. So you just find in your temperature row 76. It's 76 degrees after 4 hours. See if you can do letter C on your own. You're looking for between what 2 hours will it get to 100 degrees. Exercise 3, you have a function, y equals f of x is defined by the graph below. So it wants you to evaluate when x is the following values, okay? Remember, anything after the f of -1, this is your x, your input, okay? So when x is -1, okay, so you go back 1, what is y? 0. When x is 1, you go over 1, 1, 2, 3, 4, x is 4, or y is 4. Okay. See if you can figure out what your y value will be when x is 5. Okay, the next problem says evaluate f of 0. That's mean when x equals 0. Okay. Well, when x equals 0, then that means your point, graph, is going to be on the y-axis. Okay, so when x is 0, I don't go left or right, I go 1, 2, 3, up 3, and there my function hits it. So you have 0, 3. What special feature is that? That's your y-intercept, because it is intercepting your y-axis. For letter C, what values of x solve the equation f of x equals 0? So that is for when is y equal to 0. So on the graph, When y equals 0, that's your x line. Okay, that's your x-axis. Well, it hits it 2 times. It hits it right here. It hits it, oh no, I'm sorry, 3 times. So you've got, when y equals 0, what do you get for x? You just fill in those points where it intersects on the graph when your y coordinate is 0. That's those 3 right there. See if you can fill those in on your own. Then you've got, between what 2 consecutive integers does the largest solution to f of x equals 3 lie? So that means when y equals 3. So I'm going to draw a red line for that. Okay, so here's my y-axis. 1, 2, 3. Okay. When y equals 3, I've got 2 places, 3 places, sorry, where this function intersects that line. Okay, but the biggest one is going to be the one that's furthest out. But it's in between 2 numbers. So if you count all the way over there, you'll see that the 2 numbers that it falls between are 7 and 8. Okay, for exercise 4, for a function y equals g of x, it is known that your input value, right, g is -2, so input is x, okay, is -2, and your output value is 7. Oh, cool. Good job, Smartboard. So that's an ordered pair, -2 and 7, which you can see right here as an answer. Okay. This last exercise, exercise 5, is really asking you to use your calculator to set up a table to figure out dropping a ball from a 50-foot building and model its height as a function of time, so like how fast does it fall, with this equation. So I want you guys to save this one for class, and we'll make a table together, but I also want to see how many people know how to use their calculator to do this one.